everybody, it's Imperial Security Bureau, or ISB here, and this is the maiden video for this channel. I'm filming in Space Engine, and today we're going to do a video about a nice, very Earth-like terror which I found in the Milky Way, which we're going to explore, and we're going to assess its suitability for life. So we're currently in Space Engine, and this is a sort of universe exploration game. In a way it's not a game at the moment, it's more of a sim or an engine, but in time they will add features. Well, there's only one guy really developing it, but he will add features and such, so it's set to grow in scope and scale. So here we are in one of those sort of local outer galaxies. I don't know which one this is. No. Large Magellanic Cloud.
Magellanic.
Yeah, LMC. Right. Let's turn down the galaxy brightness a little bit. Just a little bit. That's good enough. So we don't get all the clusters showing up. It looks a bit weird. So here's our home galaxy, and what I want to show you is first of all the distance between Earth and Terra 2, as I've called it. So this is the southern galactic plane as I look at it, and this is north, this is west, this is east, and here's Earth. Right, so it's down here, down in the south. We're on, our own little spiral arm there. Now, Terra 2 is somewhere up here, so it's about three or four spiral arms away. Let's find it. There we go. Here it is. It's about 3 spiral arms away, and it's 65,000 light years away from Earth. But we're going to have a good explore of it in a moment. I'm going to go to Earth first. And here we are. We're home. Now, let's orient ourselves. There we go. Obviously, we've evolved, we've adapted to Earth conditions, and so they are going to seem very comfortable to us. Now, ideally, the most important thing for habitability of the planet, I would say, is the atmospheric composition, at least in this game. You really can't, you couldn't live on a planet comfortably if the atmosphere was all wrong. That looks like a city there. Is that Paris? I thought Paris was a bit further over. Anyway, so yeah, the atmosphere has to be right, basically, and that can be quite hard to find. I don't know if this is too loud. It sounds too loud to me. There we go. That's better. I was kind of shouting into the mic to feel like I was actually being heard. So yeah, here's England, there's Wales, and what we're looking at here, of course, is our home planet, which has a perfectly suitable atmosphere of 1 atmosphere pressure, and then that's 77% nitrogen and a small percentage argon. Nitrogen and argon, and also H2O, are they're not very important. H2O isn't inert, but it doesn't have an effect on our breathing, really, that I know of. But the nitrogen and the argon are inert, so it doesn't matter that they're there, basically. The only case in which it might be a problem was if, I guess, there was too much of them, so there wasn't as much oxygen or whatever. Oxygen, of course, being the most important one. CO2 is the more annoying one, because we can't breathe it above a certain pressure, or it's not optimal, obviously. So, and a lot of the planets you'll find out there in the vast cosmos are primarily CO2 atmospheres. Oxygen as the primary gas is about 1 in 10 of the planets out there, so, which is a bit annoying. And then of those, about 1 in 100 are actually breathable. So it is quite a hard job finding planets which you can actually live on out there. And also, of course, we got the atmosphere, the temperature. My bad, 11 degrees, 11.6 degrees, and the solar day, which is also important. Of course, you don't want to. I think you know, our sleep cycles are encoded very strongly into us, and it doesn't bode well to be sleeping on a weird day cycle. Say, for example, a planet had days of 16 hours. It might be quite tricky to figure out a sort of sleep schedule that worked. I guess you just have to sleep during the day sometimes. But yeah, we've also got a moon, of course, which is a handy little thing. And this is a fair distance away from the Earth. Was it 800,000 kilometers? Let's check that. Let's land on the surface. There we go. Oh my god. What the hell is going on? There we go. So there's the Earth. And, oh, right. It's, 400,000 kilometers away, okay. My bad. And of course it's 12,000 kilometers. So there's our beautiful Earth. No. There we go. Out there in the middle of space. And now we're going to go to good old Terra 2. Should be in that direction, if I'm not mistaken. There we go. Almost. So. Oh, I see. We're upside down. Yes, yes. There we go. I think we're aligned properly now. So let's take a gander to Terra 2, which, as you can see, is 67.29 kilolight years away. So, here we are at the local nav buoy, as I've basically designated it. The nav buoy local to the parent star of Terra 2. So this is just a cloak probe from the Star Wars add-on by, I think, Doctor of Space. Well, I can't remember. I think it's Doctor of Space. Apologies if I'm mistaken on that one. And yes, so we've got this little probe out here, and this basically serves as a guide to maneuvering into the Terra 2 system. So we've got a ISD-2 here. Maybe we should go to that. Right, so there's an ISD-2 as well, which is already in system. And but more interestingly and more importantly, we've got Terra 2 sitting somewhere very close to us, and let's just find it and have a look. ET29. As you can see, lots of exclamation marks on the in the name there. I was very excited to find one that was so suitable. So here we are. Where's the star? Oh, well, that's the planet. And here we are. Welcome to Terra 2. I'll turn down the ambient. So this is our new home in space, 67,000 light years away. As you can see, it has a natural and immaculate beauty to it. You've got azure seas and these beautiful emerald continents spaced out, these nice wispy clouds. Looks like there might be a few storms going on down there, but a very beautiful planet, and actually very hot as well. It's 46 degrees is the average temperature, with a small greenhouse efficiency of 3 degrees. And we've also got these rings, which are obviously not what we're used to on Earth, so it would be a very interesting place to live in, this Terra 2. Of course, if you look up, you'd see these rings. Let's accelerate time a little, so we can get a bigger continent which is closer to the equator. There we go, that's the one I wanted. There we go. So, let's go and have an explore, shall we? Now, as I was saying, the atmosphere on this is very suitable. Passing through the rings. Yeah, the atmosphere is very good. You will be hard pressed to find a more ideal atmosphere, really, because it's it's almost exactly like Earth's. Oh, that's weird. Oh, of course, that's the rings. Oh, it was a glitch. So let's go and have a look at a mountain range, and we're entering the atmosphere now. We've got 0.1 atmos, and at sea level, the atmospheric pressure on this planet is 0.59 atmospheres, so it's a lot lower than on Earth. It's 0.6 basically of Earth, but that is still breathable. There is a limit, I believe it's the Armstrong limit or something, and I haven't read up on it fully, but not all low pressures basically. At low pressures it becomes harder to breathe, and you can't really survive in those kind of conditions without passing out. So on this planet, what you might want to do is live at slightly higher altitudes, because it will be colder up there, and it will also be less. There will be less of the toxic elements in the air, and then you could just wear oxygen sort of, breather or something. One of those tubes that you put in your nose. But let's have a look at the atmosphere, the atmospheric composition. So here we are, and currently it's 21 degrees up here, and it's 0.4 atmospheres. 0.4 atmospheres is a bit low, so you probably need that little oxygen nose thing that I was talking about. But let's have a look at the atmospheric composition. It's 47.6% N2. It's 0.2 atmospheres, which is very similar to, 0.2 atmospheres of N2 is not similar to Earth, but the oxygen is extremely similar. It's actually slightly higher. It's 0.231, which is nice. So I'm sure you would be able to breathe it. And then the CO2, now herein lies a bit of a problem. We've got 0.07, and apparently the sort of safe limit is 0.03. So you are twice, you're 2 times as high as you want to be with the CO2, and with the SO2 you also have a bit of a problem. It should be, if I recall correctly, it should be 0.0005 would be ideal, would be like the safest upper limit. 0.001 is still okay. You can actually breathe it for a little while, but eventually it will have a negative effect on you. Which is why I suggest, if you lived I don't know, at 0.3 atmospheres and then had kind of oxygen breather, or lived a bit lower, or about 0.348. This is probably good, because obviously all the toxic elements have been kind of filtered out by virtue of the lower air pressure up here. And I don't know whether the different densities of those would have any effect. I doubt it, in terms of their concentrations at different altitudes. But I think the main thing is you could live probably quite comfortably at about this altitude. This is like 2 degrees up here, but of course we're on the equator, or we're almost on the equator, so you wouldn't have too much of a problem in terms of heat, because of course this temperature is just based on the altitude above sea level. It's not actually based on your position, your latitudinal position. So let us go and have a little explore, shall we? Note another thing. The solar day is 24 hours and 51 minutes, which is pretty ideal. Doesn't get much better than that. And of course, the temperature again is 46 degrees, which is very, very, very hot, like extremely hot. You'd have to have a sort of umbrella, a sort of air-conditioned umbrella thing that you carry around or strap to your back. I mean, it would be extremely hot. But of course, by this time, you could, by the time of actually being able to reach such a planet as this, which is 65,000 light years away, we'd have those kinds of technologies. So down here, the temperature is 46 degrees, and we've got this beautiful day on the beach. The sun is shining, the sun is high, the shadows are short, and these deep blue seas. Or this is more of a river, actually. So this is a bit like, I don't know, it reminds me of Canada or Russia, Siberia perhaps. Obviously, only a lot warmer. And we've got a weird intersection here. But there are all sorts of beautiful things to be found on this planet, and you can see the code up there, and I'll put it in the description as well. The position of it is up there in the written up there in the corner. And yeah, I'll put it in the description because I think it's worth everyone having an explore. Quite frankly, I think I've laid claim to this planet, so it's mine. It belongs to the Galactic Empire. But yeah, it's a gorgeous planet. Of course, these mountains are just breathtaking, really. And of course, you've got a lot of these plateaus up at high altitudes like this. This would be perfect to build a village or a town on, because you get a fresh supply of water. It wouldn't be too hot up here, and you'd also have the right atmospheric pressure. And then, of course, you could take a little speeder or a repulsor or something, whatever they have by then, or a spacecraft. Just take it down to the beach and put on your breather and have a swim in the very warm water. I mean, you can imagine how hot it would be. And there's your town up there, and these epic mountains in the distance. All this needs now really is trees, and you'd have an amazing sort of Canada-like, but with space rings, vista there. I just want to experiment. So. Much of a difference. Oh yeah, and I did want to show you the 50 degrees is good. I want to show you the moon as well. The moon is a nice sight. Where is it? Maybe somewhere along. Yeah, there we go. And it's such a big moon and such a bright moon that it obviously illuminates the back of the planet quite a lot. It's a beautiful thing to behold. So let's go down into these mountains and have a look at the moon at night and the sky at night. Also, you have a slightly different view here because the galactic spirals actually dissipate off into the vastness of intergalactic space, and so yeah, you've got that interesting effect which you don't get on Earth. So there's the moon. Quite a beautiful thing, I think you'll agree. Are the clouds on? Oh, they are. Let's rotate a bit so that we get the moon at daytime. Beautiful. So here we are in the day, above this pristine mountain range. As you can see, all those kinds of lines from erosion. Here we are in a valley, and where's the moon? There we go, there's your moon, and that looks like a bit of cloud. So obviously this moon being so close would have a great effect on the tides. The tides would be very large, I imagine, and it would also probably cause a lot of heating within the crust and the mantle of the planet because of that immense gravitational force as it swings around the planet at quite a high speed. And I also want to take note of the orbit pattern of the moon. It does this funny swinging thing. Yeah, see, it's going back and forth, and it basically keeps doing that until it does a slow orbit of the planet. I'm not sure exactly how long that is, but it must be several months. And yeah, so it's a very nice planet to visit. Come and visit Terra 2. There are prepaid holiday packages available. The journey time is 2 months, and it pays off. So yeah, thanks for watching, and I hope you enjoy your exploration of Terra 2 with its perfect days, its almost perfect atmosphere, and its extremely warm climate, and its beautiful, its pristine beauty. And I hope you will visit. Have a good day.